Hey guys, welcome back to the OpenTK Basics Tutorial Series. My name is Sil, and in this part we're going to be looking at doing a little bit of matrix transformations, as well as indexing our Vertex Buffer Object and making our own vertex struct. Hopefully I'll have time for all of that. What I do want to do first is the matrix transformation, since we already have stuff being drawn, it'll be easy to see. If you haven't worked with matrices before, I recommend looking up how they're used in 3D graphics. For the most part, they're basically just used for transforming vertices around. You can make a matrix that will make a rotation, a translation, or a scale, or you can combine them all together into one matrix. So they're pretty useful and pretty widespread in the 3D graphics field. But what we want to do is we want to change the screen space, what the coordinates are in the screen space. So right now, 0, 0 is the center, top right's 1, 1. That can work fine, and we'll probably reset to that, or something similar. We'll actually do a projection matrix when we do 3D stuff. But for 2D stuff, it's kind of not very helpful because we'd have a lot of floating point values if we wanted to draw to a certain little space over here and whatnot. But generally what I like to do is I like to have 0, 0 be the top left of the screen, and the screen width and the screen height on the bottom right of the screen, so that each one on the X value corresponds to 1 pixel on the screen. And the way that we do that is we do GL.LoadMatrix and pass it a matrix that we've made. And a matrix can be a matrix 4, which is part of OpenTK. So if we do this, we do GL.LoadMatrix here, and it's going to ask for a double pointer, or a array of floats or doubles. Basically, we just need to pass a reference to a matrix 4 from our side. So what we need to do is we need to make a matrix 4 variable here. We'll call this world. Generally, the world matrix is what transforms the vertices before they have any type of actual drawing done to them. So we'll do world matrix equals matrix4.create, and we're going to do create orthographic right now. Orthographic view has no perspective, and actually, sorry, we're going to do orthographic off center because I don't like to have the center of the screen 0, 0. I like to have the top left. Orthographic off center. So it's going to ask us a couple things, and it's pretty straightforward. It's asking for a left, which it'll be 0. For the right, it'll be a window.width. For the bottom, actually, I'm not sure why they have those switched around. It's more intuitive for me to have them the other way around. But window.height, and then for the top is 0. Z near is just 0. Z far 1. Doesn't matter too much at the moment. Now that we have that being created for us by the Matrix 4 class, this function is very useful, by the way. They have a lot of good functions in the Matrix 4 class. We can just do ref world here. And then if we go ahead and run our game now, you'll see that we actually have one little tiny white pixel up there if you can see it, but for the most part we got nothing drawing. And that's because all of our stuff was defined in the other screen space, and it was a lot smaller. So if we go ahead and increase the positions of our immediate mode, little penguin here, you'll see there he is. Alright, and he's actually being drawn upside down because I had switched these around. Yeah, I had switched the texture coordinates around here. There he is. Alright, so now positive y-axis is in the down direction of the screen. And one thing I do want to note, this works fine, but there is actually multiple types of matrices in OpenGL that you can use. There's the model view matrix, and there's a projection matrix, as well as texture and a couple others. Model view and projection are the two that we will use, and there's a few cool tricks that you can do with it as well. But the main thing I want to say is, whenever you're going to load a matrix, you want to specify which matrix you're loading it into first. And if you want to conserve what was already on there, you also want to make sure that you push whatever's there already. But basically, what we need to do here is we need to do GL.matrix, or sorry, GL.matrix mode is what it is. Here we are, and it's going to ask for matrix mode. We'll do matrix mode.modelview, since that is what holds our world matrix. Okay, so if we go ahead and run that now, it'll be the same exact thing. But this is important because once we get into changing the matrix mode into something different, which will be the projection, it's important to make sure that you define which one you want to load your matrix into. Alright, so let's go ahead and move on to making a vertex struct, and that's going to be basically deleting most of the drawing stuff we have and our vertex buffer object stuff. We'll go ahead and I'll leave this line, but we need to redefine our vertex buffer because it's going to be actually our own vertex struct, which we'll create here in just a second. And we're going to pass it as a well, okay, I'll go ahead and do that once we've created the struct because it'll be a little bit more intuitive here. So we're going to go make a struct here above our game, and we're going to call it vertex. And in that struct, we're going to have a public vector2 position, public vector2 texture coordinate, and a public vector4 color, which is new. We're going to have a color for each vertex, which will be kind of nice. And one thing to note is that we do need to make this a vector4 because OpenGL only recognizes vector 4s as actual colors. All of the interop stuff that we've been doing with the system.drawing color class, I'm pretty sure is done in OpenTK between us and OpenGL. So it's going to be looking for a vector 4 rather than a color variable in here. Now what we want to do to make it a little bit easier on us is instead of defining colors now in vector 4s, I'm going to make a public get and set constructor here, or parameter, so that we can set the color using system.drawing color. So what we do public color, and I'm going to do capital C color. And if we want to get it, we're going to return color.fromArgb. And it's going to ask for integers, so we're going to typecast these all as int, and the first one's going to be actually the alpha, which will be in the W value of the vector 4 color. So we'll do color.w int 255 times color.x. I can go ahead and copy this actually. There we go, and y and z, and that'll return a color. And if we want to set it using a color, we can do this dot color equals new vector 4. We'll do value dot x, sorry, value dot r divided 255f, value dot g divided by 255f, value dot b divided by 255f, value dot a divided by 255f. There we are. Now we can get and set the color with a system.drawing color class, which is nice and useful. We can go ahead and create the constructor for this here too. We'll do public vertex, and we'll ask for vector2 position and a vector2 text coordinate. Sorry, vector2 text coordinate. We'll do this dot position equals position. This dot text coord equals text coord, and this dot color equals color new vector 4, and we'll just do 1 1 1 1, which will be fully opaque white, since it's between 0 and 1, since it's floats. And that's also why we had to divide and multiply these by 255 here, so that we can convert from bytes and floats. Now this is almost done. We got a constructor here so we can make it easily. What we do need to do though to make it a little bit easier on us is to define the size of this struct and make a public parameter for it here. So we'll do public int size in bytes. We'll do get, and we'll return, since we have 2 vector 2s and 1 vector 4, we'll do vector 2 dot size in bytes times 2 plus vector 4 dot size in bytes. There we are. And we'll just have to remember to make sure that we change this here whenever we add a new value to the vertex struct here. There we are. So now what we want to do is, instead of, well, we already actually did that, we have our vertex array now instead of a vector 2 array. And now we want to define it down here, so we'll do vertex buffer equals new vertex, and we'll do like 6 like we had before. And we're going to do new vertex here and use that constructor that we made. We'll do new vector 2. For the position, we're going to just do 0 0 to begin with. For the texture coordinate, we'll do new vector 2 0 0. then we'll copy this 4 times. There we are. And we'll do 100. Whoops, 100. 100. Yeah, 100. 100. There we are. And then for the texture coordinates, we'll do something like that. Alrighty. And then we'll do, what do we want to do? Let's do like 200 and 200, 100. Oops. And we'll make it 0, 0, and 0, 1 for the texture coordinates. Now all of these default to white since our constructor doesn't pass in any, or doesn't need any color variable. It just sets it to white automatically. If you want to set one in line here, you can actually just open up curly brackets and say color equals color.red or something like that. This is kind of a, I'm not sure exactly what you call it, but you can do this in C# where you open up curly brackets after a new, actually it's the Vertex new one. After a new call here, you can actually just open up curly brackets and set variables about that new thing that you made, like since we made a new vertex, without ever having to set it to a variable and set it and then pass it. So kind of nice, makes it easier to read and whatnot in my opinion. Now when we're passing the buffer data to the VBO, we're actually going to pass a vertex class now. And instead of doing vector2.sizeInBytes, we'll do vertex.sizeInBytes. Did I spell different size in bytes? Oh, that's what it was. Okay, so our size in bytes actually needs to be a static property here. I forgot to do that as well in my testing. There we are. Vertex.sizeInBytes. There we are. Now down in our draw function, we're going to go ahead and re-enable the stuff that we did before. So GL.enable client state, and do array cap dot color array, and do vertex array and texture coordinate array. I'm going to GL.bind buffer, buffer target dot array buffer, and we'll do our VBO like we did before. We'll GL dot vertex pointer. Oh, come on. For the size, it's going to be 2 again. For vertex pointer type, it'll be float. For the stride, though, we're going to do vertex.sizeInBytes. And then for the offset, we'll do int pointer 0. Alright, and then we're going to do similar thing for texture coordinate pointer. But instead of offset of 0, what do we do here? Different. Yeah, different enums here. Float. We'll do color pointer. And float, except for the color one's going to actually be a size of 4, so make sure you change that. And then for the offsets, we're going to do, for the texture corner, we'll do vector2 dot sizeInBytes times 2 or times 1, so we'll just leave it like that. And then for the color variable, we're going to do vector2 dot sizeInBytes times 2, so we can step over the position and the texture coordinate like that. There we are. All right. And now we're going to go ahead and draw it like we did before. So we'll do gl.drawArrays, do primitive type dot we'll do quads like we had before. Do 0 for the first, and for the count we'll do vertBuffer.length. And it occurs to me that I was actually setting up our array here for when we do indexing, so we'll go ahead and get rid of these last two there. For now we just have our 4 vertices. We'll go make that 4. We'll add a couple more and do basically indexing will be nice because we can do more than just 4 vertices per primitive. We can actually do fewer vertices and more primitives depending on how we define our index buffer. Anyways, if we go ahead and run this now, you can see that we got our penguin. You can actually see that his bottom right pixel, or his bottom right vertex, is actually red, and so it's interpolating between white and red there. So that's kind of cool. We can also make like the bottom 2 pixels like semi-transparent. We can do color.from ARGB, and we'll just do like 0, 1, 1, or sorry, 255, like that. Oops, actually I don't think I need a semicolon there. We'll do the same thing for the other bottom vertex. And looks like he's not doing that. Why did I? Alright, so it looks like what was happening is we were actually drawing our media mode stuff right under our other polygons here, and so even though the second one here had some alpha to it, it was just being drawn right over the same thing. So it didn't look any different. So if we go ahead and comment this out here, you'll see that he does actually have transparency on his feet there. And I did also want to know, I just realized I'm misleading you guys just by a bit. This orthographic matrix here is actually, or actually should be put in our projection matrix in GL, because it's actually projecting an orthographic scene. It's not really a model view matrix, and we're going to be using the model view matrix for something else here so that we can move around our array without redefining it. So we're going to, instead of matrix mode.modelview, matrix mode.projection. And of course, if we run that, it'll be exact same thing, since it's it just multiplies all the matrices together in the end. But now what we can do is we can make, and we'll go ahead and name this projection instead, or proj. There we are. And now what we can do is over here, we can say matrix 4 world equals matrix 4.create translation. There we are. And for the translation, we'll do something like 100, 100, and 0. And it's going to ask for vector 3, since normally we're working in 3D world, but for now we're just working on the X and Y axis. And then we'll do GL.matrix mode, and we'll do matrix mode.modelview now, and GL.LoadMatrix, and we'll do ref world. There we are. And now you can see that we didn't have to redefine our Vertex Buffer Object at all, but he's being drawn in a different position. And this can be like a dynamic position too. We can also call draw arrays more than once and change the world matrix in between to copy him without ever having to make more vertices. For example, if we go like this, let's go ahead and we'll copy this here real fast and modify it just a bit. We'll do world. We don't need to change the model view matrix here, or the matrix mode. We'll do something like 200, and then we'll draw arrays again. There we are. And then 300 and draw arrays again. And now if we go ahead and run this, we've got 3 penguins and the same exact number of vertices. And this is so much faster than drawing each one of those vertices individually in immediate mode, because all we're changing is the world matrix and then telling it to redraw the exact same thing that it did before. So really nice. We can go, well, we'll go ahead and keep these for now. I do want to show you guys index buffers now. So what we need to do is we need to actually make another array, and we'll make this array of uints, index buffers. And if you didn't know, uints is unsigned integer, since we don't need negative values for our index buffer. And then we're also going to do int IBO, and this IBO object again is going to represent, or is going to hold the ID value for us for OpenGL for our index buffer object. And now over here we're going to say IBO equals GL.genBuffer, and we'll do GL.bindBuffer. And instead of array buffer though, we're going to do element array buffer, and then we'll do IBO. So we're just binding that index buffer object ID we just made. Then we'll do GL.bufferData, and we're going to do bufferTarget.elementBufferArray for the int pointer size. We'll do int pointer, and we'll do size of uint there, and then we'll multiply it by index buffer. Oh, did I name that wrong? Yeah, I want this to be index buffer. Index buffer.length, and then for the int pointer data we'll do index buffer Buffer usage hence going to be dynamic draw. Sorry, static draw. We don't need to change it much. There we are. GL.bind buffer and unbind it. Buffer target.element buffer array. We'll do 0. And we do actually need to fill our index buffer as well before we do this. So we're going to do index buffer equals new uint, and we'll do 8. So we have 4 vertices at the moment. We're going to make our index buffer a length of 8 so that we can draw 2 different quadrilaterals. They don't have not quadrilaterals, but quads. So we're going to go ahead and we're going to copy and make our vertex array now. It's going to be 6 vertices long. And 6 wouldn't normally draw in the quads, but since we're going to be drawing with an index buffer object with a length of 8, it'll draw 2 quads with only 6 vertices. So what we'll do is, let's see here, we'll do, instead of the y value of 0, we'll do y value 100. Just kind of flip them over there, but we'll keep the same texture coordinates. And this will effectively draw him flipped upside down just under our original quad. But now for our index buffer object, we'll do 0, 1, 2, 3. And if you didn't know, these indices are should be the number that points to the position of the vertex in our vert buffer. So 0, 1, 2, 3, and then we want to draw 2, 3, or sorry, we're going to do 4, 5, 2, 3. I believe that's right. Yeah, 4, 5, 2, 3. So that's our first quad there, and then we'll do 4, 5, 2, 3. And we'll draw that second quad with only 6 vertices. So now we'll go ahead and go down here, and then instead of using draw arrays here, we'll go ahead and get rid of these extra times here. Instead of using draw arrays, what we're going to do is we're going to bind the index buffer object, GL.bind buffer, buffer target.element buffer array, IBO. And then we're going to do GL.drawElements. And draw elements means that we have an index buffer that it's going to draw with. So do primitive type.quads. And for the count, we'll do index buffer.length. For the draw elements type, we'll do unsigned int. And for the indices, we do 0 since we've already bound our IBO and it's somewhere in OpenGL. I suppose I'm not actually quite sure exactly why it's 0, but 0 always seems to work. So it has something to do with the fact that the currently bound object is at index 0. Anyways, if we go ahead and draw that now, you can see that we got just a penguin, which isn't right. Looks like I actually need to change this. Our 4th and 5th vertice here needs to go down like 200 because these are already at 100. So it was drawing the second quad, it just wasn't really a good quad. Anyways, here we are. Now we have 2 penguins and only 6 vertices with 2 quads. So pretty sweet. And these do share the same vertices, so when we get into 3D stuff and we have normals defined for each vertex, we may not want to do this vertex sharing like this. For example, if we want a hard edge, if we have 2 different quads that share a vertex or a vertice, they'll both share the same normal on that vertice, so it'll interpolate towards that edge there. And if it's averaged, it'll look like a smooth edge rather than a hard edge. If it's in one of the directions of one of the quads, then it'll look kind of weird and kind of skew the other quad as far as lighting goes and everything. But for now, it's fine. And really useful, especially for 3D stuff when you want to draw stuff really fast and with fewer vertices and stuff. But yeah, for now, I think that's all I need to do in this tutorial, so hope to see you guys in the next one. We'll probably be working on our view class. Yeah, see you guys there. Bye.